Okay, here we are with part 3 of our video series on section 10.2 of our calculus book. And I've got a couple of applications of geometric series to work in this video. So the first one is to write the decimal number 0.372 with the 72 part being repeated as a rational number. And so let me start by just writing this out. Like so. So it's 0.372727272. And the way we're going to attack this to see that we can use geometric series to answer this question is to break this number up into pieces. And so hopefully you'll agree that I can break off this part, and so I get 0.3 plus 0.072 and then plus 0.00072 and then plus 0.0000072, and I think that takes care of the number that as I've got it written out above. So I'm splitting this up into numbers that I can add. So I'm beginning to see that I could write this as a sum. Now I know that 0.3 is 3/10. And then I'm going to convert the other numbers into fractions as well. So if I go out 3 decimal places, I'm talking about thousandths. And so this is 72 thousandths. And then the next one, if I go out 5 decimal places, I'm talking about 100 thousandths. So 72 over 100,000. And then the next one is going to be 72 over 10 million. So, thinking about things that maybe you haven't had in your brain for a little while, but hopefully we're okay. If we study this and slow down the video or look at it a couple times, we can see that this is indeed what we've got here. And so the 3/10 doesn't really match up with anything. So I've got to leave it by itself for a little bit. But I can factor out 72 over 1,000 from all the other terms. And I'm left with a 1, and then that's going to be 100, and that's going to be 10,000, and so on. But now I want to remember that 10,000 is 100 squared. And apparently the next one is going to be 1/100th cubed, and so on. And so what I see, hopefully, is that I've got a series here. Whose ratio R is 1/100th, and whose C value is 72 over 1,000. And so I can continue here. I get 3/10 plus 72 over 1,000 divided by 1 minus 100. So I get 72 over 1,000 over 99 over 100. So hopefully we're getting remembering some things about combining fractions going on here. That leaves me with a 10 there. So I get 3/10 plus 72 over 990. If I'm really wanting to do this, notice that 72 is a multiple of 9, and so I can cancel out a 9 from both numerator and denominator. I'm going to leave that this way. I could reduce it further, but I would just have to take it back up again, because now I've got 10 and 110. I would multiply the first fraction by 11 over 11. And so I can see that I would get 44 over 110. I know our calculators have ways of rationalizing decimal numbers, but here we're seeing that we can do this on our own without the use of a calculator by taking advantage of geometric series. My last problem, this section, you could read it. You drop a bouncy ball from a height of 6 feet. Each time it bounces, it peaks at a height 3/4 of the previous peak. Assuming no friction, i.e. the ball just keeps on bouncing, how many feet will the ball travel up and down? So I want to try to illustrate this a little bit. So the ball is going to drop 6 feet, and then it's going to bounce back 3/4 of what it was, and then bounce back down, and then go back up 3/4 of what that was, back down, 3/4 up, back down, 3/4 up, back down, etc. So we want to see this visual of how far the ball is traveling. So what we want to do is we want to add up this distance. We're going to have this distance twice, this distance twice, this distance twice, and so on. So I need to figure out how I'm going to add all these together. So let's see. So I've got 6 plus, and then I'm going to do 3/4 of 6 twice. And then I'm going to do 3/4 of 3/4 of 6 twice. And then I'm going to do 3/4 of 3/4 of 3/4 of 6 twice, and so on. So let's see what I can do here. So I've got 2 times 6, looks like that appears in all of these. So I'm going to have 12 times 3/4 plus 12 times 3/4 squared plus 12 times 3/4 cubed, and so on. So it looks like I've got 6 plus summation. Well, let's see. Let's stop just a second. Let's do another step before I get to a sum. I've got 12 times 3/4, and that's 1 plus 3/4 plus 3/4 squared, and so on. So now maybe I can see this. 3/4 of 12 is 9, by the way. And so I've got 9 times summation n equals 0 to infinity, 3/4 to the n. That's a convergent geometric series. So I'm going to get 6 plus 9 times 1 over 1 minus 3/4. Nine over 1/4 is 36, and so it looks like my ball is going to travel 42 feet total as it bounces up and back and forth infinitely many times.